I'm Don Clark, Director of Business Development for NEC, here to talk about the new version of Programmable Flow and our ecosystem.
I'm Sam Clements on Twitter at Samuel_Clements. My blog is sc-wifi.com.
Tony Mattke, you can find me at routerjockey.com.
My name is Jennifer Huber, and I tweet on Twitter as Jennifer Lucille, and my website is jenniferlucille.com.
My name is Jason Edelman. You can find me at jedelman.com and Twitter at jedelman8.
I'm Mrs. Y. I'm on Twitter as Mrs. Y is Y. I also have a podcast, Healthy Paranoia, because sometimes they really are out to get you. www.healthyparanoia.net.
Robert Novak, Gallifreyan on Twitter. rsts11.com is my blog.
I'm Samrat, the architect with NEC.
Yeah, so I'd like to thank everyone for joining us today. We very much appreciate the chance to talk at the Tech Field Day because really assembled some great minds and we started some great conversation. And what we wanted to do today is set up a little bit of the discussion, dive into it, and then go into our booth here at Interop so that we can show you our new ecosystem and some of the partners we're working with, and really show you SDN moving from slide-driven networking to software-driven networking. This research just came out today to talk about what users are looking for from SDN. And we've seen this movement last year of education of SDN to really what applications would be best suited for SDN, what particular problems are customers trying to solve. I thought this research was interesting because it really focused a lot on the ecosystem that we're building in terms of network utilization and efficiency being the top key issue, provisioning and automation, and improvement of security is sort of the top three things that people want from SDN. NEC's architecture really covers those three areas. We've been talking so far about NEC's control plane and data plane, and with Interop 2013, we're talking about the applications that are beginning to be built on top of this infrastructure. NEC is the only player covering the entire SDN market, from physical and virtual switching to network control to a set of NEC applications, and we'll talk about the ecosystem that we're working with. On the southbound side, the data plane side, we're working with a number of infrastructure vendors as well as NEC to deliver the data plane from an SDN solution. So NEC 5240 and 5820 switches, but also partners including Brocade, IBM, Arista, Intel, Syntec, and Extreme are being demonstrated in our booth as a data plane this SDN network can be built on top of. We also have brought the PF1000 to the market, so that gives us data within Windows environments, and with the Open vSwitch, Red Hat, KVM, and Citrix. So this is really the opening up of the ecosystem. NEC is committed to OpenFlow, and through this commitment, we've been working together with the data plane partners really to give more choice on the infrastructure that can be deployed. In terms of the control itself, NEC has built version 4 of Programmable Flow Controller. The controller has many network functions and also exposes the API. And what we'd like to walk through now is to talk about how we work with the networking partners to expose a set of network services and how they're using those network services to both get information from the network and then be able to drive activity. So Samrat's going to come up and talk about that.
I'm Samrat from NEC. So this is NEC's general functionality architecture. What it shows that, like Don was saying, in the infrastructure layer, we have different partners we are working with. And the control layer is essentially very much like the network OS, which should try to optimize the southbound layer, working with the switches to make it scalable and optimized. And in the northbound layer, what we are doing is we are trying to create two sets of APIs. The one set of API is a network information plane, and the other is the control plane. And you can think of any higher layer application with a Debian orchestration framework like, let's say, OpenStack, or maybe different appliance companies who want to get into more of a network-aware type of an application can sit on top of it, consume these APIs to start interacting with the network in an integrated fashion that did not exist in the legacy network as flexible or as agile. So what are the things which we are doing in the control plane? The control plane is supposed to provide certain level of keys, tools, or optimizations that the higher layer doesn't have to worry about, because it is too much to go on, trying to optimize the network, trying to deal with all these different type of devices. So let the control plane take care of that. So what are the things we are doing is that we are trying to ensure that if you have a switch plane, then we can create multipath to create more bandwidth optimization. We are also working about how to scale the number of flows into the core network or the core switches so that your entire system can scale. We are also talking about how we are optimizing, let's say, the number of messages which are going to the secure channel, because that's another scalability criteria we are talking about here. We are talking about how to do auto VLAN configuration so that you totally automate the network, don't even have to go into the level of any port level configuration things. So these are the features which the programmable flow controller or our controller is continuously adding in terms of reducing the operation level of complexity, or in trying to optimize the network in a more better way or add scalability. And as you know that we are in a version 4 of the product, and we have been adding all of these features to help that. However, from the higher layer, the idea is that you just provide these features so that they do not have to worry about all this optimization scalability part. At the same time, we are also going to support the 1.3 very soon in the next few months, so that all the switch vendors who will support 1.3 can now start working or interoperating with the controller. And in the booth, we'll show how many switches that we are interoperating with the OpenFlow 1.0. So the other part now, let's go back into the higher layer, the information and the network control. The information is becoming a very important part of overall solution development, and these are the solutions which are basically driving the SDN. A simple scenario, we'll talk about in the next few slides, is that how the information, dynamic information from the network, or even static information, but continuously changing information, like let's say the topology of the network, or the load of the network, or where my MAC stations are located. All of this information can be collected by high-level orchestration of the appliances, and then use the network control to go and make changes into the network in a dynamic basis. So what the OpenFlow is doing, if you look at it, is that it is essentially allowing such a dynamic network control, which can be a closed loop type of a control where you consume the information and make dynamic changes. Let's say I have a congested path and I want to change the link metric so that the new path be selected, and those information you can directly derive. But the important point is you can also use the network control API because of the OpenFlow underlying to make dynamic changes in the flow injection into the network so that you can take care of those behaviors. So here, this is a general architecture of us. We have also added various features into it. For example, like you can see here, we have supported IPv6 both in layer 2 and layer 3 forwarding. We have added QoS control where you can do policy-based control, can do marking on the packets, and they are all happening at the, you can add it at the ingest level or ingress level, so that you can actually make those traffic polished before it enters into a more of a routing domain. And we have also added other features related to, like I was saying, in terms of minimizing the total management complexities in the whole network, and so that you don't have to do a lot of configuration before you set up a OpenFlow network there. So this is basically the number of some of the preliminary, I would say, applications or appliances that are interacting with our SDN. And the reason to bring it forward is to essentially talk about some of the business drivers where a solution can make unique use of the SDN that it could not in a normal legacy world. So I'm going to create some sort of a context of these scenarios so that when we move into the booth, you can essentially see them, some of them in action. So in a high level, there are the type of application appliances we are talking about is on the management side, on the security side, and the optimization side. On the management side, some of you are already aware of our SDN management tools. You can see that how we can have a full visualization of the network through a user interface. We can even create and deploy a network right from like clicking on the panel and then get networks deployed. So that's a NEC's own thing. We have also adding up a ecosystem where anyone can come in and use our REST APIs to start creating his own application. And one of that example is Real Status. What they are doing is very interesting. What they're doing is they're able to collect this information from the REST API and provide a very detailed visualization of your entire network. And that's something very exciting for people who want to see in a large network with large number of VMs connected in a big data center, how this whole thing is connected, how the traffic is moving there. And that is one of the things we want to encourage, is to enable that all of these apps or people who want to create more visualization tools or management tools can come and use our APIs and then create more valuable story for the operations. On the security, we have two particular use case. One is the Radware, and the Radware is essentially a DOS mitigation use case, and it shows how the APIs are consumed in a closed loop manner. So what is happening is a Radware controller is essentially taking the information and the packet counts from the network for a given flow. So it's a great part that you can say, oh, I want to add my service, a DOS mitigation service, not to every flows, because that would be maybe not a scalable thing, but maybe those flows which are hitting my critical services. And I can go and say to the controller that, just look into or monitor this set of traffic, maybe to certain ports or maybe to certain IP address.
So you're going to toss it? Or what triggers? Is it going to initiate triggers so that you're going to do something on the OpenFlow network?
Yes.
Okay.
Yes. So using the APIs, you can go and install certain filters, and those filters will be mapped into certain matching criteria. Can be a server IP address or ports. Based on the filters, the OpenFlow switches is going to provide the traffic statistics back to the controller. Again, using the APIs.
But is there a hook already? You're saying that, so I don't have to use the API. Right?
You have the not-bound APIs. The not-bound APIs, okay. If you look into this particular slide.
So northbound, I'm going to have to use the API. Southbound, will I?
Southbound is all using standard OpenFlow. So that's the important point, that you're not changing anything. It's a standard OpenFlow which allows you to go create filter or flows and also get statistics out of that. So all you're using is a standard OpenFlow interface.
Are you using anything but OpenFlow between the controller and switch for management, configuration management, versus just managing flows?
Just OpenFlow.
So the Radware appliance speaks OpenFlow. That's how you're getting it south.
Radware appliance is using our not-bound because it's a non-OpenFlow appliance. So the Radware appliance is using the network information to get information, and then using the network control to go and change the flows. And that's what I'm going into. So what it is doing is, if you look at this diagram, it make it much easier to understand. If you look at there, you can do packet metering. You can see there. So what it is doing is, it is identifying certain flows and doing packet metering to find out if there is a possible DOS attack going on. It doesn't mean there is a DOS attack. It may be a case for a DOS attack. When it finds that or establishes that, then it uses our network control to go saying that those flows which are possible DOS attack will have to be redirected to a Radware DPI engine, which is the real, hardware engine that can go inside the packet and then detect there is a DOS attack and scrub the traffic before it enters into the final destination.
Okay, so the intelligence for detecting the DOS is you're putting the thresholds and the metrics inside on the switch.
The switch will just monitor. Switch will not.
Right, but it makes the decision on whether or not to go send it to Radware or Scrub.
Exactly, but that is driven by the Radware. Exactly.
Radware pulls stats, analyzes it. If there's something bad.
Okay, so there's the analysis part, and then it sends like a yes, no. Okay.
Yeah.
It's got
Have you looked at
maybe
maybe throttling too?
You can. That is another use case I'm coming to, actually. So this is, but remember, we are not, we are just trying to enable things. And that's an important point here. This use case is actually a Radware-driven use case from what they are saying on the problems. Is that you can't go on buying all these hardware appliances and they become a choke point. Rather, what you're doing is that only when you're seeing a DOS attack, you are using those DPI appliances.
Yeah, that's really smart because otherwise, because otherwise you have to create that network security layer or the inspection layer in your network, and that gets really onerous and expensive. Yeah, this where it's a trigger. I mean, I know IDS is out there. Some of the new open source like Bro is doing stuff like that using OpenFlow triggers.
Yeah. And why it is so difficult in a legacy? Because if you want to change a flow, a specific flow coming into your network to a Radware device may be connected at some point in the network on a dynamic basis. Those are the challenges.
Well, why be heavy-handed too? I mean, why redirect to everything? I mean, you can use, if you're OpenFlow intelligent, then you're doing it more granularly and selectively, right?
Yes.
Is that the point?
Yes.
You can copy it too. Make the flow normal and also just copy it.
But that is one of the important points. But the other important point we are hearing from all these different appliances that when you add an appliance and when you want to shift the traffic to quit through that appliance, like a service insertion, it is difficult in a normal legacy network. Like we'll see in another case, like if you want to add like certain appliances, then you have to make some adjustment in your VLAN or your static routing configuration or maybe in your WCCP. So those are difficult, but here you can add that appliance and shift the flow or redirect the flow dynamically, right on an application-based driven.
The question's on the slide deck. How are you doing QoS? My question was, are you doing a netconf or a SNMP aside from OpenFlow to configure other things?
For the QoS part?
Yeah.
QoS,
as an example.
Yeah, QoS is okay, good question. So let me go a little bit onto the QoS part.
Yeah, that's good.
What we are doing here is a flow level QoS, which is one of the important addition in the OpenFlow world. That you can say that you can define a flow like an OpenFlow flow, right? An OpenFlow flow is a flow based on a matching condition. So let's say I want to say that any traffic which is coming from this particular IP address block or any traffic, let's say, going into this particular port has to be metered, and then I want to mark them, or I want to even add some sort of a drop-in policy on that. So these are the three things we are able to do at this point at the flow level. We are able to meter the traffic. We are able to apply it like a three-color type of a policy on there, the yellow, green, and the red. So, and then on the yellow color, which is in the level of the middle, we are able to do any sort of marking, so that when it goes into the router and others, they will then be driven through their QoS scheduler.
Some vendors are doing their own extensions to configure COS or DSCP. I was just wondering if you were doing that or just doing.
It is using the vendor extension.
And then, how heavy-handed is it? I mean, how much work? I guess this is at its infancy, right? So I'm going to be doing a lot of programming, right? At this point, when you guys, is it on the roadmap to make it smoother for those of us?
For the QoS part? For the QoS, you're asking?
I mean, for these kinds of triggers and communications back and forth between.
The good part is because it's all API based. You can just write any program and start using them.
I know.
And it becomes
I know, but a lot of shops.
You can do like Python,
we're not all
want.
you spend so much time learning certain, certain parts of your job. I mean, now you've got to go out and become API programmers as well. I mean, so when are you guys going to make it easier for us?
That's a very good question. Like, some people are asking, all right, I had this way of managing network, which was basically CLI based, and now, am I becoming like the programmer guy, which is doing all this API? And that's a
and that's not a problem, but in your day, you still have, I got to do incident response and intrusion detection and everything else. So now I got to take time out to work with the networking guys who aren't programmers anyway. What are we going to do? Go get the developers, and they're going to help us write to APIs, because those are the only guys in my organization that know anything about writing. I mean, are you guys trying to make it
easier?
Yeah. I mean, when somebody comes to me, a lot of times in the past, and I'm not saying it's you, but sometimes they come to us and say, well, we have a fully published API. It's like, definitely.
That's a lot of this stuff is written already, and you can, if you're decent at scripting, you can spoon a lot of this together. I mean, that's what a lot of us do programming-wise
is it on,
anyway.
like, through the OpenFlow site or through their site? I mean, is it still pretty crunchy right now, or is it?
Okay, let me answer something on there. You're right. In some sense,
say
API. API means many things. Is it a complex API? Is it like every switch API? And that's a point, right? So we didn't discuss here in this particular presentation. API needs a model on the rate. If you do not have any good model, then API means nothing. I can create 1,000 APIs, and you'll say, what does it help me, right? So the NECs, if from the historically, this whole controller, what it really added as a value to the whole thing is creating a network model. Because if you lose the network model, all the OpenFlow provides is a switch model. And if I just provide you, go to that switch, inject this flow, do that, then you're lost.
Yeah, but you hear our pain, right?
Of course, that's the exact reason we created the network model, so that you have very simplified APIs. And that's the reason you need a model behind the API, because the API doesn't by itself create the story. API with the right model, simplified model, basically creates the story.
So can I call you when I'm like, right? Can I? You said this was easy.
So okay, let me give you a certain example. Why this?
It's easy to create a marketplace for other people to charge you to do this for you.
Yeah.
Well, see, that's, and I'm wondering. When is
Well, no, but I think it brings an important question, or a statement. I'll say it's just a statement, not a question. A question came up on a meeting I was in last week. We were talking about implementing, it was channel partners, right, or systems integration partners, discussing how to integrate OpenFlow-enabled technologies into current product offerings. And the question came up, hey, does this mean, I'm a CCIE, I've been a CCIE for 10 years, right? Does this mean I have to become a programmer?
Yeah.
And it's funny, the manufacturer who was speaking was like, no, we sell tools, so you don't have to do it. I said, you're effing wrong. Absolutely, as everything in our work becomes software defined, utilizing software tools, software development methodologies is a key and critical part of existing in that world. And having an understanding of distributed systems, of networking, of best practices is good for that, and I think it's a firm foundation. But we absolutely need to evolve. And the question that I saw,
I think that's a very good comment.
Yeah, it's just hard right now in the organizations we have right now. I'm so busy triaging, hemorrhaging patients that for me to sit down and and then work out with the networking guys. Hey, we need some programming today.
Well, but it's more than that. So if you think that there's a shift towards test-driven development inside of software development, moving from SDL software development lifecycle, 6 to 12 months to create code, to agile methodologies, which normally 2 iterations are deploying production feed. They're going from inception to creation. That same high velocity method of creating software, as our entire infrastructure that we're discussing today is now defined to be a software. We have to fit into those models. And so it's as important in that case to be able to write the test as well as the feature. And it's actually one of the questions I have. So I was on the floor yesterday, and I'm trying to pull, a Twister, open source OpenFlow modeling, right? So one of the questions I've had to a lot of the manufacturers pushing their OpenFlow enabled devices right? Is are you guys releasing test suites integrations into like continuous integration systems like Jenkins? The ability to me, now that my network is described via software, to be able to fully model that, test that before deployment, and integrate it, frankly, have the NEC functions in this case integrated in my software development deployment systems?
Well, that's what I was referring to as a model.
Yeah.
That we lack the model in a normal network, right?
Yeah.
The model is essentially also adds predictability or network in a consistent behavior. But when you, we have actually sort of dived because we have been talking for a long time. We have skipped that whole part of the network model actually. The network model decouples your configuration from the functionality so that you do not have to worry about the consistency. Today, I create my some QoS metric and I see that the end-to-end behavior is inconsistent. Who is going to find out that there is inconsistency? Creating the network model which NEC has created is that you do not have to worry. We'll ensure that end-to-end, the entire system is consistent before you even go to
I would say that I don't need to worry, I absolutely need to worry, but I need to make sure that in my quality assurance methodologies that the network functions are, every change in my network is modeled and tested in QA and then streamed into production.
Yeah, somewhere it is automating that and it will let you know. If
I use automated tools right now to regression test software features that roll in. In OpenStack.
Yeah, but not everybody does. But it's all of a sudden you're turning your network into like it's just as much development as say your web team or everything else. And all of a sudden that's a huge shift and that's a shift in personalities that
And initially, it's either going to hurt or it's going to lock out the really small shops that might want to move in.
But if you look at, there's other software vendors that have virtualization products that are absolutely trying to software define the data center, right? And I believe that that level of networking is very much accessible to the small scale commercial shop. You can always purchase something on I would say commercial companies kind of use virtual, on VMware, kind of easy. Probably easier than use Cisco, HP, NEC, whoever, right?
Yeah, the problem is, though, that then they try to scale. Some of the bigger companies want it to be as easy as that, and it doesn't scale in terms of either the cost or the size. It gets so complicated.
It's like it'd be like trying to use MRTG once upon a time to manage an entire network.
What's wrong with that? I still do now.
I sent DVDs to Totally. That guy's awesome.
Yeah, so going back to a point, I think the abstraction layer which NEC creates is to reduce those level of quality testing and everything. So that much of the things are actually already taken care by the network model that you do not have to go into the complex ways of quality and regression testing. So that's the virtual tenant network model. We'll introduce a little bit there and we'll see how it actually reduces these complexities for you.
In your design, you mentioned you had the full stack earlier. So if we deploy NEC, virtual switch, physical switch, are you using OpenFlow across the board or just for the vSwitch, doing standard L2, L3 to the physical network?
Standard L2, L3 you can deploy on OpenFlow 1.0.
And now I guess what you can do, what's the preferred model? If it's going to be a full NEC stack in the data center, would it be just OpenFlow between controller and vSwitch and then manage the physical network differently?
No, all 1.0, all OpenFlow. Whether the vSwitch and the physical switch,
top rack,
all of them, yeah. So it's right now it's an OpenFlow island. Right now that's the deployment model we have here. Right? But it is evolving into the place where you will be able to manage both legacy and things, but that is a higher layer. That's over the controller layer, say orchestration.
But your guys' product support ships in the night, right? We can have a distributed system running, OSPF or BGP, and then layer on flow tables on top of it concurrently, correct?
It is the BGP and the others are essentially a little decoupled from the conversation protocol, the chat protocol. So right now, as you know, the controller can go and put your flow table injection there. Yeah. But you can add like any other router also, or hand up the traffic to a router.
Yeah, because you guys demonstrated some early leadership in that space. So you guys may have already covered this. I'm sorry for coming in towards the middle part, maybe. Did you guys cover your contributions to Open Daylight?
Yeah, we're gold members of Open Daylight, and we've actually proposed the VTN model into OpenFlow.
So that's the model which we are discussing, which actually simplifies that. That is the NEC's greatest, I would say, the innovation in the whole SDN, and that's what we are putting into the daylight as a part of the whole.
How do you compare the VTN model versus a standard virtual L2 segment?
It's a good question. So VTN model is not like a specific to L2. It gives you a total network modeling, which means a bridge, a router, filters, ACLs, redirection. So it gives you a topological model. And it's much more flexible and agile in terms of expressing your needs, as opposed to just say, give me an L2. For example, the OpenStack model, right? So OpenStack just gives you an L2. L2 model is more of an object type of model. You just provide certain parameters and you can do that. The VTN model is essentially a creation of a network, total network, and you can create like multiple different virtual networks. Each can operate independently. In one network, you can provide like just an L2 network. Another, you can create a complex L2, L3 with filters, policies there. So that's the type of model which we have brought in there.
Samrat, we're going to want to show them the demo. So
yes. So,
and I know they have a hard stop at 2:30.
So what we have in the demos, and that's the context I wanted to share here, that most of these demos are essentially driven by the appliances. And as you know, there are load balancers, there are security appliances, and there's certain difficulties they are facing today. And most of the difficulties are driven by the need to virtualize that. Like today, for example, a case of load balancers. I mean, you have a certain traffic for batch delivery, and that is creating a huge traffic for only, let's say, Tuesday. What do? You buy it for all the capacity today, and then tomorrow they're all unused. So all of them are becoming virtualized, not just the VM, but the appliances. But then the question comes is that when you try to virtualize that, you're firing up all these different appliances. How do you use a network that can, support this stuff for elasticity, support balancing between that, multiple VMs, supports high availability? Because now you do not have a very good cluster system probably. Like, one particular appliance goes down, you have to ensure that, the traffic gets automatically routed there. So these are the things which are essentially scale out, high availability of these appliances are driving a lot of needs in the SDN, and what is also one of the things we are going to show you. And the third important thing is the orchestration. So we have OpenStack support of the SDN using the NEC plugin. Which allows you to automatically create a network of physical host control and the physical switch control and the virtual switch control. And the important thing is that you can fire a VM and then associate the VM with the given layer 2 network, totally automated using the OpenStack integration with the SDN. So these are the two important parts we're going to show here. And maybe we can move, unless you have any other questions on the
One last question, I guess, for customer traction. Are you seeing a lot of the traction being pulled through or driven by OpenStack, leveraging Quantum API, or are you seeing it more generic in the data center?
It's a very good question. So the OpenStack driver is becoming, I would say the traction is building up in the last few months. I think they are driven mostly by the stability of the OpenStack. We all know that with the Folsom release, there is some level of stability we have gained in the quantum. It's still to be done. There are still a lot of scalability issues, like still the routing agents are a bottleneck in the OpenStack world. So they are trying to bring out the scalability on the routing and the load balancers as they move. So this is the time where we are seeing traction, but I think on a practical deployment level, it will take some time to get into maybe Havana, and where you will see more of a real deployment cases. So I would say that the traction is building up to know how this whole thing is working, let's say with the SDN at this point of time. And we are going into so many of the lab deployments with them.